A great day, one and all present here. And first of all, I would like to thank for joining today's presentation. We are going to see is the optimal design solutions for material handling equipment manufacturers. So, what are the product we design, we manufacture? It should be withstand the load we apply. So, the number of prototypes and the number of prototype cost will be radically increased. The repeated failures. The how strength is my product, will it withstand the load we apply? The how long my bearing will last for the continuous loads? So this much of questions will rise when we manufacture any product, any components. So let me see by one, and how the software solution will be a great one. Actually, this is one of the bracket. I have in my mind the different kinds of designs. In this much of four designs, which one will be the best designs? Which one will be the best bracket for the withstanding of the loads which fixtures in the frame that are stood by the two ends and acting on the load on the upper surface of this bracket. And we see the next one is the different kinds of frames, and actually this is one of the 16,000 Newton capable load acting on the upper surface of this frame. And will be provided for the gussets, which is stronger and how much it will be stronger, and whether if I provide a gussets, at what degree, what angle should I provide the gussets, the respective angles. For an example, the 30-degree, 45 or 60-degree for the material, same material I maintain for the same number of welds, etc. And the next models, the beam slice, which supporters, how many number of bolts should I induce to maintain a consistent load, withstand the load for this much of two splices. For an example, the 32 bolts or 18 bolts or 44 bolts, with maintaining of the factor of safety greater than 2. So these kinds of designs, how shall I maintain, and how shall I know where the load first begins, where the failure first begins, and how much long will it withstand, and where the maximum material I used, and really the material thickness is required to withstand that load, or am I wasting the material more, or I am designing over designing the products. So actually this is one of the frame here. I am going to validate this frame whether it withstand the load or not. So on the left side the property manager, you see different kinds of analysis. Here I am done a static analysis whether the product, the load acts on the upper surface of the model, will it withstand or not. It consists of different solid bodies. Here I am how well we made a project in the real time environment, like fixing the fixtures like into the ground, or the nuts and bolts we provide to fix the models, two components, and the forces acts upon the over the body like that, whether it may be a force or torque, etc. So here different kinds of fixtures, like whether it may be a bearing fixtures or the roller slider fixtures, or the one end support and other end is free movements like that, and the forces, the pressure, gravity, and the torque, whether whatever may be the force. Here for an example, I made a 5,000 kilogram force which acts on the upper surface of the project, here the model. So here I am going to evaluate this project whether it will withstand the 5,000 kilogram force or not. So here the stress indicates me the on the right side you can see the chart options that the blue color indicates me that is a safe load, that the allowable material thickness is good, and so on the increasing on the from blue to red indicates me the critical values. So here the maximum stress induced in this 5,000 kilogram force model is 10.524 megapascals. And not only that, we can also evaluate the displacements, the strain, the factor of safety, and how much of material is taken for the load to withstand, where the material is allowable more and where the material is less, and more, so on and so on. So, and not only that, we can also study the deformation where it starts and end of the stress distributions, etc. like that. So here for an example, I just want to share another one of the example is the and the lifting equipments like the jeep crane. Actually, this is one of the model, and the motor travels to and fro of the frame. The motor will carry the hook with any kinds of loads, and it with a respective force like a 500 newton or the 1000 newtons or whatever it may be. The force induced in this roller when it moves is acts on this surface. So what should I do? Whether I just want to evaluate whether this beam, this structure will withstand the load or not. So I am going to evaluate this model. You can see the different kinds of structures. Here for an example, I just make a fixtures which is grounded through the fixed geometry by using the number of bolts. Actually, I will ground through a bolt. So this I have made a fixed geometry, and the forces acts on these surfaces is by through and joints. So that pink color ball points indicates that these are the joints, and I'm going to act the force, induce the force on a one respective joint, that is the load on a point load with 3000 Newton force. I am going to work for an instance. So here I have applied the 3000 Newton for force, and let me see what will be my static analysis. Static report says that and the displacement and the strain, etc. So this is a static stress analysis report and the displacement report like that. The maximum 20 mm displacement will be has been occurred in my 3000 Newton force and the strain. And let me see how the distribution of the strain is working in this model for the 3000 Newton force. So you can notice that the distribution of the strain has been equally distributed whether wherever it distributes or it is like in connectors through the beams. The different node sets I have been applied and the fixed geometry on the bottom of the bracket, etc. And also not only that, I would like to show is one of the best example for this solid simulation analysis. What about the bearing selections? What the bearing should I provide to withstand the load for the different kinds of shafts? Whether the shaft has a more torque producement, and it will the torque produced in the shaft will then my bearing produced has been will be withstand or not. So the different kinds of analysis I can do, and this is one of the bearing selection analysis. So here, since it is a shaft, cylindrical shaft, I have introduced the two different kinds of forces. The first one is the normal force, and the next is the torque. Obviously, everyone know that the rotational shaft produces the torque with respect to its axial directions. So here the fixed geometry I have provided for the four corners, that is nothing but a bolt where I fix into the ground. And next one is the force. Here what I told that I to the downward directions that I provided the 100 Newton force, which is normal to the ground. And the next one is the torque, and the torque I provided here for the 183 Newton meter torque I provided with respect to its axial directions. So let us see what will be the results of this. So by acting on the 100 Newton force and the 183 Newton meter torque, the resultant stress will be the maximum of 18 megapascals. So the equally distributed area of the stress will be indicated notated by the blue color, indicates me it is a safe load, and my factor of safety of this model is the 12. Yes, of course it is a safe, and the factor of safety indicates me 12 times the material I applied is very good strength to withstand my load. Here, for a clear understanding, I just changed my factor of safety with limitations of 50, so that the blue color to the red color indicates me severity of the material. So here the failure occurs, so that red color indicates me where the failure begins first, with the axial rotation of 183 Newton meter torque force. And let us show you the different kinds of stresses, not only the volume stresses, the principal stresses with respect to the different directions x, y, z, different normal stresses, and where I can also able to check whether the different material load conditions, and by using the slider to a continuous path between the loads and resistance can be easily adjusted, and the transcribed portions of the design inside plot carry the applied loads less effectively than the solid portions. So here notice that the blue color indicates me that the material is enough to withstand the load. So the next we are going to see is an interesting analysis, that is nothing but the well strength analysis. Here this is one of the well strength model, and here I'm going to show you how the well strengths can be easily applied and can check whether the weld I apply will withstand the load, and if it is not, and what the weld thickness should I make for that. So actually this is a bracket, and where these two edges will be the load acting area. So I am going to provide the load on the two edges. So here in this time scenario I have fixed the two edges of this bracket, and the bearing loads I induced for the 10,000 of Newton with respect to the y directions are the two edges of this bracket, and this is the area where my load acts. So in this cases, let us check on the stresses where it starts begin the failure, and here the maximum stress of 2,908 megapascals, and the red color indicates me the severity level of the model where the failure begins. And let us show you the displacements of 66.7 mm displacement will be occur with respective to the 10,000 Newton. Here the estimated weld size is 10 mm, but yes, of course it is a safe, and the calculated weld size shows me the 11 mm, and this size the 29 mm of the weld size. So, and also the SolidWorks suggests me the best solutions if suppose I need any attentions or like that. And here the bar graph, the graph shows that the weld size, the clear understanding of the clear table, the weld size and the weld throat size, the joints where I induce the two components with respective graphs. So here the x-axis lies between the weld seam distance and the y-axis has the weld size. So here you can clearly understand that how the load will acts upon the 10,000 Newton force where the weld I apply to the two joints, the one solid to the other surface models. So how the estimated weld size and has been calculated, how the SolidWorks simulations knows the mismatch of the thickness I induce. So let us show you how we can calculate and estimate the weld size here. So actually in this property manager, this is a well connector properties I have to induce here. The two surfaces, this is the two mating areas where the cylindrical parts and the planar surface meets, and the single sided weld I have induced with different kinds of electrodes. And not only that, the weld strength will be automatically taken with respect to the electrodes I choose. And here you what I told, that 10 mm weld size I have been introduced, and the next edge I have been introduced make a similar 10 mm weld size. So actually here what I told, the results will be okay, and if it is any attention needed, it also SolidWorks simulation automatically suggests me if there any attention is needed, so that we can concentrate on the area where the require thickness or the material we need. The next important chapter is the motions. As I told in the PPT, whether if I'm carrying a 1000 Newton weight force, To lift 1,000 Newton, it's really a 3 HP motor is required to lift 1,000 Newton, or the less amount of power is enough to require 1,000 Newton. Am I over designing the project? And for an example, the 3 HP motor is required to 1,000 Newton, or 2 HP motor is enough to lift 1,000 Newton or not. So with the real-time environment, I can create the gravity I introduce in this model, and the power consumptions. The output can be evaluated by the respective power consumptions and the maximum number of forces with respect to the Newton, and the time with the respective time. For 5 seconds, the maximum power consumption is can be evaluated through the graphs, and for the 5 seconds the maximum Newton force estimated through the 1,000 Newton force. So, and not only that, the motors, so the cylindrical or the linear motors or the rotary motors, I can make it. And not only that, the springs, dampers, and the contacts between the two components, and the cam actions can also be easily done in SolidWorks motion. So the gravity I told here with respect to the 9.81, gravity can also be applied. So this what gravity is introduced in the real time, how it acts towards the downward direction. So you can find that the simulation can also be easily done through the setup we define. Where if I lift the model, where the deflection starts begin, and what will the maximum deflection deformation of the model if I lift 1,000 Newton, like that. Actually, the final result can be estimated through a power consumption, so that I can able to take this much of HP motor, so that to lift this much of weight with respective time. So the bar graph will be definitely useful for the SolidWorks simulation users to evaluate their project, how much of HP the motors will be selected for the weight they induce in the model, and the force, maximum force, what will be the maximum force within the time estimated. So these are the things like estimating the validating the project I do, and the motion, the motor selections, like that. And coming to the PPT, which practice mount is based on the analysis we show, the double web 4 bolts or the double web 3 bolts. We can see the different parameters like that, and ultimately we conclude that by analyzing this bracket with different kinds, the short web 4 bolts is the best solutions with respect to the parameters. The maximum deflection is 0.18 mm, like that, and the base frame, the 30° or 45°, 60°. Based on analysis, we conclude that the good, better, and best with the specifications, the safety factor of 3.40 for the 60° base frame, and the beam slice for the 32 bolts, the factor of safety is 1.98, or the 18 bolts 1.2, and 40 bolts of 1.2. So ultimately, the goals you can achieve is you can validate the product you design in a design stage itself. The exact motor specifications can be easily selected for the load you apply in the design stage, and you can let the know area where the failure begins, and the rectification process can be done within a design stage. The maximum load where it occurs can avoid the failure in prototypes. Material wastage can be reduced, and number of prototypes and the prototype cost can reduce radically. Achieve return on investments very quickly by experiencing SolidWorks simulation. So, in case of any designing the product or validating the product, regarding the more and more on SolidWorks product, you can contact us at any time and any technical clarifications.